Okay, guys, in one of your homework assignments, there's a problem like this. Basically, what you have is you have a small mass or a ball that has a mass and then it's released. Uh, it is released from a height h and it falls on this object, right, or the ramp, and it has a 45-degree angle, and then basically that is also 45, and this guy is 90. And what I would like to do is I would like to find the velocity of the ramp after the collision. So as you probably know, if this guy is going to fall here, this guy is going to go to the left. How do I find the velocity of this guy to the left? I want to stop here. I would let you guys work on this problem, think about it, and then watch the solution. Okay? Try to do it on your own before I solve it right now. And now I'm going to actually do the solution. So what is the velocity of this ball at here? Well, we know the velocity, and I'm going to refer to them as Vm, right? Is going to be equal to square root of 2gh. And by now, all of you should really know this at the top of your mind. Alright, now let us draw our momentum and impulses relationships, right? So, obviously we need to know the coefficient of restitution, right? There is a coefficient of restitution between this one and this one. Okay, so what is how do I draw this? So basically what I have here is that I have this is a mass m, right? And this guy is gonna have a momentum which is m multiplied by vm, right? And let us actually do something. Let's call it vm1, right? So we know the velocity of mass 1 is before the impact, right? And then likewise I'm gonna do v capital M1 to be the velocity of the bigger mass before the impact. So at the impact, basically I'm going to have an impulse, right, that is between this guy and that guy, and because this angle is 45-degree, and perpendicular to this will actually be 90, but towards the horizontal it will be actually 45-degree, right? So my impulse is gonna be inclined at a 45-degree angle, and let's actually call this as FDT. Okay, so this is our FDT, and then after, what is going to happen here, basically we know that M is going to be flying with some velocity, right, or with some momentum, and we don't know how this guy is going to fly, right? So it's going to hit here, it's going to go with some angle, right? Might be like that, like this, like that, we don't know. So I'm gonna actually put it like this, as this guy is gonna be going with mvm2, and mvm2 is essentially the momentum of this mass after the impact. Okay, all right. So now we don't know this, right? And let's keep track of something, right? Let's keep track of this, right? This line, which is a 45-degree line, right? And let's also keep track of our line of action, right? It's always a good idea to keep track of your line of action, because you would actually need it sometimes when you are needing one more equation from the coefficient of restitution, right? So this is our line of impact, right? Line of impact or line of action, right? And let us actually call this angle theta, right? Let's call it theta. All right. Theta is basically the rebound angle with respect to the line of impact, right? Remember, always you want to do it with respect to the line of impact. All right. So this is it for the first mass, and let us look at what is going to happen at the second mass. So this is the second mass, right? And the second mass is initially at rest. It has no velocity, and then all of a sudden basically the ball hits it, and now it's going to have an impulse. So you know that this FDT is going to be equal and opposite on this guy, right? This is your bigger mass, and also during this impact the gravity is actually applied, but you actually have RDT, right? RDT is the reaction due to the ground, and you have mgdt from this end. So mgdt is going to be very small compared to RDT, and then to FDT and then RDT, right? This is why we said we ignore gravity in the case of an impact, right? So f dt is gonna be much greater than mg, right, as a result of the collision. You would actually include mgdt if you were to integrate this. If a ball is falling and you try to apply this, you integrate fdt, you'll actually realize that you are going to end up with the same equation that we calculated before with Newton's equations, or Newton's second law of motion. Alright, so these are the only impulses that are applied on m, and what is the momentum of this m after the impact? It's going to be horizontal, right? And it will be m vm, and we only have vm basically, and I'm going to actually label it vm2. Alright guys, so this is really a big portion of the problem, and now we would like to find Vm. How do you find Vm? We have a lot of unknowns here, right? We have fdt, we have rdt, and then we have velocity, right? So how many unknowns do we have technically? We have one unknown, right? We have another unknown, rdt, and then we have the third unknown, right? How many equations do we have? Well, we have conservation of momentum on this guy along the line of action, right? So we have one momentum equation in that direction, and we have momentum equation of this guy in that direction, and then we have the equation of the coefficient of restitution. So these are three equations, and then we can solve for the three unknowns. Let us do it together and then see how we are going to do this. So I'm going to begin by summing the momentum or the impulses of this guy in that direction, in the direction of the line of impact, right? And if I do this, it's right here. So you can see it. Alright, so if we do this, right, if we do this, what do you get? So you're gonna sum the impulses in that direction on mass m. You are going to get f dt. What is this angle? For mv minus m vm1. So I think this angle is going to be 45 degree, right? Why? Because this angle is here 45, right? This angle will be 45, and then this angle is going to be 45. Minus mvm1, cosine 45 is, you all know, square root of 2 over 2. And that is going to be equal to how much? To m vm2, right, cosine theta, right? So this is the final momentum along the line. So I'm summing the impulses and the momentum. So this guy had a negative momentum along this direction, and then it had this force, right? This force has pushed this guy to go in that direction, and also I can sum the momentum in that direction, and I'm going to end up, if this is a positive direction, then this guy is going to contribute to a positive angle, right? And then what is going to be this angle? This guy is 45, then you know this guy is going to be 45 degrees, right? So how do you do that? Then you're going to have m vm1 cosine or sine 45 degree, which is also square root of 2 over 2, which is going to be equal to this guy, right? Is going to be equal to m vm 2 sine theta. Okay, so we have mvm1 sine 45 degree, which is square root of 2 over 2, is equal to mvm2 sine of theta. All right, now we can apply our coefficient of restitution equation, right, along the line of impact. If you do this, what do you well, remember, we actually have okay, let us actually continue, and then before we apply the line of impact, let's actually do this on this side, because this will simplify some stuff. So if I sum the impulses in the right direction on mass on the ramp, right, what do you get? So this is f dt, this is 45 degree. You are going to get what? F dt times square root of 2 over 2 is going to be equal to m vm2. So vm2 is directly related to fdt from here, right? All right, no need to actually find the RDT, right? So all you have to do is just sum the impulses on the left direction, and then you know that FDT is going to give you that velocity, and we can actually get FDT from this, right? So what remains for us to solve is gonna be the velocity of the small mass after the impact, right? And then we also need to know the angle. So let us see how we can apply the coefficient of restitution. So if you actually apply the coefficient of restitution, what are you going to get? So the coefficient of restitution is going to be along this direction, right? So this is going to be my line of impact, right? So E is going to be equal to how much? The velocity of, remember, E is going to be equal to VB2 minus VA2 divided by VA1 minus VB1, and this is along the line of impact. So what is the velocity of the thing that is being hit after the impact? So the velocity of this guy, right? But you're projecting this along the line of impact, right? So E is going to be equal to V capital M, right, square root of 2 over 2, which is cosine 45 degree, minus the velocity of the ball after the impact, right? And I'm assuming this is my positive direction for the line of impact. So this is going to be actually minus, right? Minus, because this guy is in the opposite direction, minus, right? V minus, right? So this is minus, Vm2 cosine of theta, right? And the reason why you have that is we assume, well, first of all, I'm projecting this velocity on the line of impact, but because this is opposite to my positive sign, which I'm assuming right to left is along the positive direction of the line of for the coefficient of restitution, then this guy is going to be minus, divided by VA1, right? The ball that is hitting. So VM1, right? Projecting this guy along the line of impact, square root of 2 over 2. Minus VB1, which is 0, right? There is no velocity of the bigger mass after the impact, right? So that is going to be equal to what? VM2 square root of 2 over 2 plus VM2 cosine theta divided by VM1 square root of 2 over 2. Alright, so what I have here is I can now, I will take FDT, I'll make it equal to MV2. So I'm gonna put V of the velocity I'm trying to find, I can basically put it in that equation, right? And I know VM1, right? We know VM1. FDT, I'm gonna make it equal to this. So I'm gonna take this guy, plug it here. And I know this, I still need to know VM2 cosine theta 2. So from here, I can say that I can actually substitute VM2. I can find it in terms of VM2. So basically I'm reducing my unknowns to be able to actually solve for VM2, right? So E multiplied by VM1 square root of 2 over 2 is going to be equal to VM2 square root of 2 over 2 plus VM2 cosine theta, right? So I'm going to take this guy, VM2 cosine theta is going to be equal to E VM1 square root of 2 over 2 minus, alright. Okay, so this is your VM2. So this is equation, let's call this equation 1, 2, 3, and then this is your coefficient of, so I plug 4 and substitute 4 in 1, right? So 3 and 4 in 1. What do you get for FDT? FDT, you're going to get 2 over square root of 2 VM2, right? So FDT is going to be 2 over square root of 2 MV2 minus VM1 square root of 2 over 2 is equal to VM2 cosine theta is given to you directly here. Is going to be equal to E Vm1 minus. Alright, that is it. So from here we can actually solve for Vm2 because we only have Vm2 right now, right? So let's simplify some stuff. I'm gonna multiply by square root of 2, right? And then divide by 2. So let us, if you multiply by square root of 2, you're gonna end up with 2 m Vm2 minus m Vm1, because this guy will vanish if I multiply by square root of 2, is gonna be equal to m e Vm1 minus m Vm2, right? Okay. Alright, so everything is cancelling out. And in this problem, so where are we right now? Okay, so we are trying to find Vm2. So I'm gonna Vm2, right? 2 bigger mass plus smaller mass is gonna be equal to m Vm1 1 plus e. Alright, so your result, so Vm2 is gonna be equal to Vm1 1 plus e m divided by 2m plus m. And in the problem, which is in part of the assignment, we have m is equal to 3m. So Vm2 is going to be equal to Vm1 1 plus e. 2 times 3 is 6 plus 1 7, and that is the solution. So please check this problem and then verify this, and make sure you are very confident in doing this problem the way that I just did it. Okay guys, so this basically wraps up this chapter, right? Make sure you know that the coefficient of restitution only applies along the line of impact. Make sure you are very confident how you're applying this. Make sure to keep the sign of velocity of the ball that is being hit, the velocity of the ball that is hitting after the impact. So all of these are assumed positive in the same direction, right? So if one of them is, in this case, we assume everything is positive in that direction. Here, because we assumed it like that, then you have to take it into account. That is why we have the minus and then the minus. Okay guys, so next chapter is going to be kinematics.